It's the world's most popular ice cream flavor, the go-to choice for birthday parties, apple pie, and late-night comfort eating. Vanilla ice cream seems simple enough. Just cream, sugar, and vanilla, right? Well, not exactly. Get ready to have your mind blown about that innocent scoop in your freezer. Creating perfect vanilla ice cream requires more precision than making Swiss watches. The real challenge isn't mixing cream and sugar together. It's controlling ice crystal formation so precisely that a single degree of temperature variation can turn premium ice cream into expensive frozen disappointment. Today we're going inside the factories where dairy science meets frozen perfection, where a timing mistake of just 30 seconds can ruin thousands of gallons, and where the difference between smooth, creamy ice cream and icy, grainy mess comes down to understanding the physics of freezing. So grab a spoon. We're about to dive into the surprisingly complex world of creating America's favorite frozen treat. Every batch of vanilla ice cream starts with something most people take for granted: milk and cream arriving at the factory in massive refrigerated trucks. Ice cream manufacturers work with specific farms that can guarantee consistent fat content, because even a 0.5% variation in milk fat can completely change the final texture. The milk arrives at exactly 38 degrees Fahrenheit and gets pumped into enormous stainless steel silos that can hold up to 50,000 gallons. But before it can become ice cream, every single tanker truck gets tested for quality, fat content, and bacterial levels. If even one truck doesn't meet standards, the entire load gets rejected. Here's where things get interesting. The milk and cream don't just get mixed together randomly. There's actually a precise formula that determines the perfect fat content for creamy vanilla ice cream. Heavy cream contains about 36% fat, while whole milk has around 3.25%. Ice cream manufacturers blend these in exact ratios to achieve 14 to 16% fat content, the sweet spot that creates that rich, creamy texture without being too heavy. The dairy also gets standardized, meaning the fat content is adjusted to be identical across every batch. This involves separating cream from milk, then adding back precise amounts to hit that target percentage every single time. What emerges from this process is a perfectly consistent dairy base that will behave predictably during every step of ice cream production. Now comes the part where vanilla ice cream gets its signature flavor and sweetness. The standardized dairy base moves into massive mixing tanks, where sugar, stabilizers, and that all-important vanilla flavoring get added in precise amounts. The sugar isn't just for sweetness. It actually affects the freezing point and texture of the final product. Too much sugar and the ice cream won't freeze properly. Too little and you get hard, icy results. Most vanilla ice cream contains about 15% sugar, carefully calculated to balance sweetness with proper freezing characteristics. And here's where things get really specific. The vanilla flavoring process is way more complex than most people realize. Real vanilla extract comes from vanilla beans that are processed into extract that contains hundreds of different flavor compounds, each contributing to that complex vanilla taste we all recognize. Some manufacturers use natural vanilla, others use artificial vanillin, and many use a blend of both to achieve the perfect flavor profile. The mixing process happens in enormous tanks, with giant paddles that blend everything together for exactly 20 minutes. The temperature is carefully controlled at 40 degrees Fahrenheit to prevent any bacterial growth, while ensuring all ingredients dissolve completely. Stabilizers like guar gum and carrageenan get added to prevent ice crystals from forming and to maintain that smooth texture during storage. These might sound like scary chemicals, but they're actually natural ingredients that help create the creamy consistency that makes ice cream so satisfying. What comes out of these mixing tanks is a liquid that tastes like melted vanilla ice cream, sweet, creamy, and packed with flavor, but still completely liquid and ready for the transformation head. Before the mix can become ice cream, it needs to go through two critical processes that ensure both safety and texture. First up is pasteurization, where the mix gets heated to exactly 175 degrees Fahrenheit for 25 seconds to kill any harmful bacteria. This might seem counterintuitive, heating something that's going to be frozen, but pasteurization is essential for food safety. The heating process is precisely controlled because too much heat can actually change the protein structure and affect the final texture. But the really cool part happens next during homogenization, where the mix gets forced through tiny holes under enormous pressure. Homogenization pushes the ice cream mix through screens with holes smaller than a human hair, at pressures of 2,000 pounds per square inch. This breaks down fat globules into microscopic particles that distribute evenly throughout the mix, preventing separation and creating that smooth, uniform texture. Without homogenization, you'd end up with chunks of butter floating in your ice cream. Definitely not the creamy experience you're looking for. The process also helps the mix absorb more air during freezing, creating that light, scoopable texture. After homogenization, the mix gets rapidly cooled back down to 40 degrees Fahrenheit and stored in aging tanks for at least 4 hours. This aging process allows the proteins and fats to fully hydrate and stabilize, which improves the final texture and makes the mix easier to freeze. By the end of this process, the liquid mix has been transformed into something that will freeze into perfect ice cream every single time. Next comes the part where the real magic happens, turning liquid mix into actual ice cream. The process takes place in continuous freezers that look like giant metal cylinders. But they're actually sophisticated pieces of equipment that control temperature, air incorporation, and mixing with incredible precision. The mix gets pumped into the freezer at 40 degrees Fahrenheit and emerges just 6 minutes later at 22 degrees Fahrenheit as soft-serve consistency ice cream. But those 6 minutes involve some serious science. Inside the freezer, the mix gets churned by rotating blades while being cooled rapidly. The churning is critical because it prevents large ice crystals from forming. As the mix freezes, air gets whipped into it, increasing the volume by about 50%. This is called overrun, and it's carefully controlled to create the right texture. The freezing process happens so quickly that ice crystals don't have time to grow large, which is what creates that smooth, creamy texture. The rotating blades constantly scrape ice crystals off the freezer walls, keeping them small and evenly distributed. Temperature control is absolutely critical during this process. Even a 2-degree variation can affect the final texture, so the freezers are monitored constantly and adjusted in real time. What emerges from the continuous freezer is soft-serve consistency vanilla ice cream that's ready for packaging but still needs to be hardened to reach that perfect scooping consistency. The soft ice cream gets pumped directly into containers, whether that's pint containers for retail or 3-gallon tubs for restaurants. The filling process happens incredibly fast, with machines capable of filling hundreds of containers per minute while maintaining consistent weights and preventing air bubbles. The containers are immediately sealed to prevent contamination and freezer burn. But here's where the final transformation happens. The packaged ice cream goes into hardening tunnels that are colder than most home freezers. The hardening tunnels maintain temperatures of -20 to -40 degrees Fahrenheit, rapidly freezing the ice cream to its final consistency. This process takes about 2 to 4 hours, depending on container size, and it's where the ice cream develops that perfect scooping texture. Quality control happens throughout the packaging process, with samples taken every 30 minutes to test for proper texture, flavor, and temperature. Each batch gets tracked from mixing through packaging, so if there's ever a problem, they can trace it back to the exact source. By the time the containers emerge from hardening, they contain perfect vanilla ice cream that will maintain its quality for months in proper storage. Before any ice cream leaves the factory, it goes through rigorous quality testing that would make a laboratory proud. Texture analysis measures how easily the ice cream scoops and how it melts on the tongue. Flavor panels taste every batch to ensure consistent vanilla flavor and detect any off tastes. The ice cream also gets tested for proper overrun, fat content, and bacterial levels. Even the packaging gets inspected to ensure proper sealing and labeling accuracy. The distribution process is just as critical as manufacturing because ice cream has to stay frozen throughout its entire journey to your local store. Specialized refrigerated trucks maintain temperatures of -10 degrees Fahrenheit during transport. The trucks are loaded strategically to minimize temperature fluctuations, and delivery routes are planned to reduce time outside of freezers. Retail stores receive training on proper ice cream storage and rotation to ensure customers always get the freshest product. The entire cold chain from factory to freezer aisle is monitored to maintain that perfect texture and flavor. By the time you grab that pint from the store freezer, it has traveled hundreds of miles while maintaining the exact same quality it had when it left the factory. Despite being called plain vanilla, this flavor is actually one of the most complex to perfect. Real vanilla contains over 250 different flavor compounds, making it more chemically complex than chocolate. The global vanilla market is worth billions of dollars, and ice cream manufacturers are constantly working to source the best vanilla while managing costs. Vanilla ice cream serves as the base for countless other flavors and desserts. It's the foundation that supports everything, from root beer floats to apple pie a la mode. Getting vanilla right means getting the fundamentals of ice cream manufacturing perfect. So the next time you're enjoying a scoop of vanilla ice cream, remember all the precision science that went into creating that perfect creamy texture and rich flavor. From dairy standardization to controlled freezing, every step is carefully engineered to deliver that satisfying experience we all love. What's your favorite thing to pair with vanilla ice cream? Drop your vanilla preferences in the comments below. And if this video made you appreciate the science behind your favorite frozen treat, hit that like button and subscribe for more behind-the-scenes food manufacturing stories.